Good evening again, everyone. So, going back to our last topic, which was the periodic table of the elements. So, the table being flashed now in your screen is the periodic table of the elements, and I do believe that it's not new to you since it was already discussed to you by your previous chemistry teachers. So, there are three classifications for all of the periodic table of elements. Um, These are the orange ones, which is a nonmetal, like for example the hydrogen, the helium, the carbon, the nitrogen. For the metalloids or the semi-metals, these are boron, silicon, arsenic, and others. For the blue one, we have here the metal ones, or for example, the lithium, beryllium, sodium, magnesium. They are classified accordingly to their properties. No, similarly, the nonmetals are do share some properties. No, that they are closely related with the also with the metalloids and the metals. No, in the near future, we'll be discussing the differences of their different properties. So again, for the microscopic perspective or those that can't be seen with our naked eye, solid, liquid, gas. Solid are particles that maintain a regular ordered structure. They maintain size and their shape. No, since the again, if seen in a macroscopic perspective, solid is a hard one, and they are not easily they cannot easily change shape. Now, for the microscopic, is still the same concept. Solid are particles that do maintain a an ordered structure. No, dili siya dali deform. They have their own specific sizes and they do have shapes. Now, for liquid, no, they remain close, but not necessarily in any order. No, they take shape all of their container. Example, for example, of that is the liquid. No, so, if you'll be putting a liquid onto a circular glass of a circular shape, no, of a glass, no, then it will take the form of the glass. For the gas, they are particles that are widely separated to each other and they move independently of one another and they fill available volumes of container. No, so if you will be comparing the three, a solid is close to each other, no, as much as possible. They have to stick to each other, no. For the liquid, they don't necessarily have, no, to remain very close, but and they also have no order, and also they take the shape of a certain container. And for gas, no, they move as freely as they can. So during a physical change of a microscopic perspective, no, um, chemical composition does not change. No, for example, you'll be heating a liquid water into into a boiling, no, temperature. So when liquid takes off or changes its property into a gas form, no, so if it condenses back, it becomes liquid. So it doesn't change its composition. No? It's still H2O. Just that after its boiling point, it became gas. And then when it condenses back from gas to liquid. Still, it's H2O. But when you say chemical change, it is a chemical reactions that occurs that changes, no, chemical composition of the matter involved. For example, water. No, when you convert water into or when you separate water into hydrogen and oxygen, as we all know, water is composed of two hydrogens and one oxygen atom. No, when used when used by an electricity, no, they separates and they no longer now an H2O molecule but an individual oxygen gas and hydrogen gas. So it changes form, no, from H2O into oxygen gas and hydrogen gas. No, you can differentiate the changes since for the physical change, no, they are of still the same elements. H2O, but it's in a liquid gas, to an H2O, but an H2O gas. Pero sa chemical change, no, H2O separates. It becomes hydrogen and oxygen, and after converting them into molecules, they don't go back to its original form na H2O liquid. So for example, a candle is being suspended above a boiling water that could use to test an hypothesis about the chemical composition of the bubble that rises from a certain boiling water. So what would be observed if the bubbles were composed of A, water, B, hydrogen, or C, oxygen? So in other words, no, naay gibutang na candle on top of a boiling water. And what if, no, what if the bubbles that is being produced on a boiling water is water or hydrogen or oxygen, no, because they are elements, no, as we all know, elements do have their own properties, no, different ang ilang chemical reactions sa different scenarios. So water, as we all know, H2O, pag H2O lang gani ang sulod, no, sa boiling water, ang mahitabo sa candle is that since mabasa man si candle kay water man, no, from liquid to liquid gas, no, it's either muhinay ang spark ni candle or mapalong siya, since as we all know nga pag mabasa ang fire, no, mawala magid ang fire kay mabasa. But if hydrogen ang i-produce na element ni boiling water, no, for example, we have used an electricity, no, to separate the hydrogen from the oxygen, no. So basically we all know nga si hydrogen, grabe kina siya ka-reactive. So naay possibility na nimubuto si candle nga naa sa boiling water. However, no, kung oxygen man gani ang i-produce na gas sa boiling water, no, ay possibility na na ang spark ni candle will enlarge, no, mudako ang fire, no, kay since combustion man siya. So yes, if the bubbles, no, coming out from the liquid contain water, we would expect the flame to diminish in size or be extinguished. Water does not sustain the chemical reaction of combustion, just like oxygen. So if the bubbles are water, the flame should not burn as brightly. So now, hydrogen, you should be able, no, to find in the internet, or as what I've explained earlier, that hydrogen tends to burn explosively. So if the bubbles coming out from the water were hydrogen gas, we would expect to see the flame ignite the gas with some sort of an explosion. Hopefully, it's just a smaller one. For the oxygen, no, if the bubble were oxygen, the flame should burn more brightly, and the amount of fuel would remain the same, but the bubbles would increase the amount of oxygen present and make their reaction more intense. So, when you say dihydrogen oxide, no, it's what we call sa water. So, tungod kinaa siya hydrogen and oxygen doesn't mean nga same ang ilahang properties sa individual nila nga elements, no? Kay when i-combine nimo si hydrogen and oxygen, simple ra kayo ang iyang reaction with water, no? Mapalong ra ang fire. But kung imo siyang i-separate, kung imong i-separate si hydrogen, imong i-separate sa oxygen, lahi gyud sila nga properties. So kung si hydrogen na possibility nga mubuto ang katong ang namubuto, no, tong kandila nga naa on top sa boiling water. Pero naman kung oxygen ang gina-release ni boiling water, no, iyang i-fed hinuon ang fire, no, dili siya mobuto, but it will make the flame more brightly, no, mo increase ang iyahang flame. So now going the symbolic representation, as we all know, chemistry is full of symbols. We have theta, we have omega, but more simpler in simpler chemistry, no, elements are being described in a two-letter, no, or one letter lang. So when we say the element abbreviation Al, no, this is being described as the pure aluminum, just aluminum alone. But when you say aluminum oxide, it is now Al2O3. No, the numbers that are subscript, no, sa elements will be discussed in the following topics. No, so when you say Al, no, as being described sa periodic table, it is pure aluminum alone. But if it says aluminum oxide, no, its elements symbolic representation is Al2,3. So here, the particulate level representation for aluminum oxide is Al2O3 in bauxite. So it is the or the so-called alumina. So this is the element, no, aluminum oxide. The silver one are the aluminum, and the oxygen is the red one. So on the right side, this is a pure aluminum. So the particulate level representation for pure aluminum is Al. So as you can see, the macroscopic, so as you can see now, the macroscopic structure is the water. You can see the water that is being fed into the battery cell. When you say the microscopic, so the microscopic is the elements that is being produced when being separated, no, when water is being separated into hydrogen and oxygen using electricity, no, they separate, and in microscopic, no, we cannot see the hydrogen and we cannot see the oxygen being produced, but it's there, but it can't be seen into our naked eye. For the in symbolic levels, no, how do we describe the elements that is being produced in the reaction? We describe them as H2O, H2, and O2. So they are all present in any chemical reaction. For the chemistry is an empirical science. So when you say empirical, what does it mean? It is based on observation. It is based on experiments. It can be explained thoroughly, and it is just not a simple theory lang or simple marites lang from our neighborhoods. It is being studied. It is being studied by measuring physical properties and by observing chemical reactions. So they are being described by numerical and real situations. There are also models that can explain these observations, and there are various collected data that are being produced in order to prove the existence of chemistry. So the observations are recorded via measurements or through numbers and through units. That's why I have told you before that units are a very crucial elements in chemistry. So there are two types of observation via measurement. Accuracy. When you say accurate or accuracy, no, this is on how close the observed value is the true value, or kung unsa kaduol ang imuhang na-retrieve na measurement sa tinuod na value, the true one, the one that is being kanang tatong gusto na value, no? But when you say precision, is the spreading, no, sa ato ang na-acquired na values na datas, no, through measurements, no, the reproducibility of values. So kung naatay nakuha na mga datas from our experiment, no, we should see how close our measurements, no, to each other. Kay since in our experiment, no, we won't be just doing one trial lang, kay bias man siya. there is that minimum no trials of 3. So dapat when you say precise ang imong measurement, your 3 trials should be close to each other. But when you say accurate, your 3 trials should be close to each other, at the same time close to the true value that you have calculated through theoretical calculations. So for example, for these 3 diagrams, A, B, C. So when you say your measurement is accurate at the same time precise, no, the your data for your 3 trials are so close to each other at the same time your target value, which is the violet one, the full circle, 4 violet circular one, is your true value. So duol na sila, they are within no the true value that you have calculated in your papers, at the same time the values that you have gained from your experimental data. No, they are so close to each other, so they are the perfect example of measurements. So accurate and so precise. When you go to diagram B, no, you can see that the values that you have gained from your experimental data are so close to each other, but they are not close, no, they are not within the true value that you have calculated from your chemical reactions, for example, no, from your chemical or from your balancing equations. So the data you have obtained is precise, but unfortunately they are not accurate, no, layo ra kay sila sa imuhang gusto na value, no, that was according to your calculations. And for the diagram C, as you can see, the datas no are so far from each other, dili sila magkaduol, no. So this is an example of not accurate. Not accurate. Why not accurate? Because they are not within no they are not within the true value that you wanted, no, at the same time they are not precise because they are too far from each other, no. So again, the observations are recorded via measurements. It is a numerical units, no. They have to be accurate and they have to be precise. Again, accuracy is how close the observed value is to the true value, and precision is the spreading of values obtained from measurement or the reproducibility of values. So for example, we have an example here. Suppose a QC chemist at a pharma company is tasked with checking both the accuracy and the precision of 3 different machines that are meant to dispense 10 ounces or 296 ml of cough syrup into storage bottles. She proceeds to use each machine to fill 5 bottles and then carefully determines the actual volume dispensed, obtaining the results tabulated in table below, and identify whether the results are accurate and or precise. So naay three, no? Naay 3 different machines nga the chemist was tasked to check the accuracy and precision. So these are called the dispenser 1, dispenser 2, and dispenser 3. And she was tasked to give 5, no? 5 bottles, no? Meaning 5 trials. And then carefully, she then determines the actual volume of each volume that is being dispensed, no? As seen in the table below. So for the first bottle, no? Dispenser 1 dispensed 283.3 ml. For the second bottle, 284.1 ml. For the third bottle, 283.9 ml. For the fourth bottle, 284 ml. And for the fifth bottle, 284.1 ml. So our target ml should be 296 ml. What do you think is wrong, no, with dispenser 1? Is it accurate enough? Is it precise enough? Or are they accurate and precise enough? For now, going on to dispenser 2. For the first bottle, it dispenses 298.3 ml. For the second bottle, it dispenses 294.2 ml. For the third bottle, 296 ml. For the fourth bottle, 297.8 ml, and for the fifth bottle, 293.9 ml. No? As we can see, the values are so far from each other. No? What do you think is the description of the dispenser 2? For this dispenser 3, the first bottle, no, 296.1 ml. Second bottle, 295.9 ml. Third bottle, 296.1 ml. For the fourth bottle, 296 ml. For the fifth bottle is 296.1 ml. Now, what do you observe? The datas are so close to each other. At the same time, the datas are so close to the target value. So what do you think is the answer? Or what do you think is the description of each of the following dispensers? No, for dispenser 1 again, no, the datas are so close to each other but too far from the true value. For the dispenser 2, the values are so far from each other, no? From 298 to 294, it is so far from each other. At the same time, they are too far, no, from the real value that we wanted, which is 296 ml. For the dispenser 3, no, the values are so close to each other, no, that the difference is just like zero point 0.1 or yes, zero point 0.1, 0.2, but they are also so close to the true value that they wanted, which is 296 ml. So I believe that you already have guessed, no, the answer. So yes, dispenser 1 is precise. Why do we know it's precise? Because the values are so close to one another within just a few tenths of a millimeter. But they are not accurate because they are too far, no, from the target value, which is 296 ml. No, too low. For the dispenser 2 naman, there is an improved accuracy, no? Because each volume is less than 3 ml away from 296 ml, but the values are too far from each other, so it's a worse precision because they vary for more than 4 ml, no? So it do have a good accuracy but worst in precision. Now for dispenser 3 is the best one since we can see that it precisely and accurately no dispenses the cough syrup into the bottles because all the volumes is within the zero point 0.1 ml of the target volume, which is the 296 ml, and precisely because the volumes differ from each other by no more than 0.2 ml. So, measurements may have two types of common error. These are called the random error and the systematic error. When you say random error, they make a measurement randomly too high or too low. No? For example, variation associated with equipment limitations. No? For example, the equipment dispenses different volumes of liquid, no? So they either give too high, no, na too high or too low error. And we also have a systematic error. They make measurement consistently too high or too low. For example, the presence of an impurity, or for example, in a sack of rice, no, nagsagol sila og in a pure rice, nagsagol sila og bato. So that makes the sack of rice um, impure, no? Kaya dili naman siya exactly just a bag of rice. No, so the stones that was being thrown into the sack of rice are what we call impurity. So, for inductive and deductive reasoning, no, are used to interpret collected data and and observations. Now, we have two types of reasonings: inductive and deductive. So, these reasoning are used to interpret, no, collected data and observation. So, syempre, when you've got your data from an experiment, no, you have to interpret them. How? By inductive and deductive reasoning. Inductive reasoning begins with a series of specific observations and attempts to generalize to a larger or more universal conclusive. Now, when you say inductive, no, there is this specific observations, no, specific observations, but it can explain a general knowledge or a larger or more universal conclusion. No, gamay lang kaayo siya na observation, but applicable na siya into a large scale of observation or conclusion. Now, for deductive reasoning, it takes two or more statements or assertions and combines them so that a clear and irrefutable conclusion can be drawn. So deductive reasoning is, it has a various no statements, daghan kaayo statements, daghan kaayo observations or assertions, no, and then they are being now combined in order to make a clear and irrefutable conclusion. So inductive reasoning is from a specific observation down to a lot, no, a larger conclusion, or daghan na siya ma-explain. For deductive reasoning is daghan explanation, and then that daghan kayo explanation, when you combine them into one, no, they become clear and irrefutable conclusion that can be drawn. So models, no, models in science. Models in science refer to a largely empirical description. For example, gas pressure is proportional to temperature. Now, when you say models, no, we put symbols sa models in order for us to pinpoint, no, a certain um, empirical description, in order for us to explain a certain experiment, no? For example, gas pressure. When you say gas pressure, it is proportional to temperature, no? When you say temperature, it's called T, and for gas is G, no? It's gas pressure is proportional to temperature. For theories naman, theories are explanation grounded in some more fundamental principle or assumption about the behavior of a system. For example of that is the relationship between gas pressure and temperature explained using kinetic energy. So theories, as we all know, they are explanation, no, grounded with some principle, no. So naa mga certain principle, no, na gina-explain si theories, while laws are sufficiently refined, well-tested, and widely accepted theories. So when you say theories, daghan pa siya explanation, no, in order to make a certain assumption true, but si law is a universal truth, no? There is a kanang automatic na siya. When you say law, it's there. It's final. But when you say theory, kinahanglan pa siya i-back-upan og mga explanations and assumptions in order for you to be able to explain a certain behavior of a system. So, going on to the numbers and measurements in chemistry, no? When you say units, no? Units is not new to you since it designate a type of quantity measure. For example, kilo, no? Kilo, millimeter, no? For the volume. Kilo is for, is kilo, ml, no? For the volume, no? For the weight, itong kilo. When you say degree Celsius is for the temperature, and so on and so forth. When you say prefixes, no? They provide scale to a base unit and significant figures, indicating the amount of information that is reliable when discussing a measurement. So when you say, kinahanglan ng two significant figures in order for you to explain a certain measurement, no? So, what are your bases, no? In nganong kinahanglan two numerical numbers lang, no? So later on we'll be discussing how to designate a certain unit, a prefix, and significant figures. So for the units, so the base unit designates the type of quantity that is being measured. So for the mass, we have here kilogram. For the time, no, we use seconds. For the distance is meter. For the electric current, no, we have ampere. For the temperature, Kelvin. The number of particles is mole, and for the light intensity is candela. So this is the SI units of system. When you say SI, this is like the from the French Système International, the base units of science. So they are more commonly used, no, internationally, no. When you describe a mass, it has to be in kilogram. When they are asking for your time, it has to be expressed in seconds. when you are being given the distance, you have to express it in meters and so on and so forth. So some units comprise combinations of these base units and are termed derived units. For example, derived units are, for example, a combination of two terms. When you say 1 kilogram per meter squared over second squared, no, this is so called 1 joule. So this 1 joule joules is now called the derived units of the combinations of kilogram, of meter, and seconds. We do encounter a lot of this in the thermodynamics and mostly soft physics. So we have there the prefixes are used with base units in order to report and understand quantities of any size. Like for example, 1000. So it is now the prefixes on that is 1.00 times 10 to the power of 3. So for the macro scale, no, we can use it for the height of the human, for the sheet of paper, for the wedding rings, no. Uh, For the microscale, no, the thickness of a CD, since it's too small, no, the plant cell, the animal, mostly sa biology, bacterial cell, and animal cell, no, the macro scale, no, the things that cannot be that cannot be seen in our naked eye. But when you say nanoscale, kato na gyud bitong di na gyud nato siya ma-observe, no, even they have to be observed in a specialized state of the art, no, facilities, no. For example, microscope and stuff, no, yung sa mga viruses, protein molecules, aspirin, the waters, and the atom. Well, basically we can see the elements of the water, no. So it's in a um nanoscale, no, measurement. Also atom, we cannot see hydrogen, for an instance, in the environment. We cannot see hydrogen, we cannot see oxygen, no. So they are in a nanoscale world, no. As we can see, um scanning scanning tunneling microscope and electron microscope, optical microscope, can observe, no, molecules in a microscale and in a nanoscale um, scale, but our human eye only for the macro scale. So the SI prefixes we have here, the 10 to the power of 24 factor is called iota, or the symbol, it symbolizes Y, no? Um, 10 to the power of 21 is zeta, 10 to the power of 18 is exa, 10 to the power of 15 is peta, 10 to the power of 12 is tera, and so on and so forth. So prefixes are based on the multiples of 10, so they have to be expressed in tens, like 10 to the power of 24, 10 to the power of negative 1, 10 to the power of negative 24, no? So it has to be, more good na siya. Prefixes are based on the multiples of tens. So for the temperature, temperature is measured using there are three, no? As we can see, these are the Fahrenheit, the Celsius, and the Kelvin, which is the absolute temperature scale. So when you say zero for the temperature, it has to be 0 Kelvin as the absolute temperature that is being accepted in the SI units. No? Dili sila pare-pareho, as we all know, no? So for the boiling point of water, when you say Fahrenheit, it has to be in the 200, no, 12 Fahrenheit. Pero in Celsius, no, 100 degrees Celsius. And for the Kelvin, or the absolute one, is the 373 Kelvin. So they have their own conversions, no, as we will. Yes, as seen in the screen, no, when you convert Celsius to Fahrenheit, um, it has to be 1.8 times the degree Celsius plus 32. Take note of the open parentheses, no, they have to be multiplied first before you add 32 into the equation before you can get into the degree Fahrenheit. For the degree Celsius, no, the degree Fahrenheit, no, value is being deducted first into 32 before you divide it into 1.8. For the Kelvin, no, when you convert Celsius, degree Celsius to Kelvin, the degree Celsius plus 273.15. You can get now the Kelvin unit. For the degree Celsius, no? If you'll be given the Kelvin, no? Kelvin unit minus 273.15, and then you'll get the degree Celsius, no? There is a necessity for you to familiarize the conversion of unit because there are in other countries, no? Ang ilahang ginagamit mostly is Fahrenheit, degree Fahrenheit. For the Philippines, we uses mostly degree Fahrenheit. So ato ang mga aircons, no, as we can see, they are mostly expressed in degrees Celsius. But when asked, no, sa Fahrenheit, no, so para bitaw dili kaayo ta maglisod, you have to familiarize it in order for you to answer, no, na kana mga simple equations na unsay conversion ani from degree Celsius to degree Fahrenheit. So for the scientific notation is used to easily write very small and very large numbers. No, factor out powers of 10. Again, it's expressed in the multiples of 10. For example, 54,000. So 54,000 is too long. But in scientific studies, no, and mostly in calculations, they are expressed in scientific notations. It is expressed in 5.4 times 10 to the power of 4, which explains as a 54,000, and 0.000042 is equivalent to 4.2 times 10 to the negative power. So, these are the guidelines in the scientific notations. All digits reported are considered significant except for certain type of zeros. So when a zero establishes the decimal place, it is not significant. No? So when you say 51300, there are only 3 significant figures. Since the rule says when a zero establishes the decimal place, it is not significant. But if the number is on the right side, it only have 2 significant figures. A zero is significant when it follows a decimal point when it occurs between other significant figures. So 4.30 ml, we have there 3 significant figures, and 4 significant figures 304.2, no? So again, it is not significant, no, if for example in 51,300, no, since walay decimal in between, no, so the 513 is only be considered, no, significant figures, which is 3. Here naman 0.043 dilin apilon ang 0.0 since it is not significant already, so it's like 2 significant figures. The only thing significant are the following, no, it follows if it follows a decimal point. Since 4.3, 0 is being followed in a decimal point, so it is a 3 significant figures. Also 304.2 naa siya in between sa significant figures, so it is considered 4 significant figures. So all numbers are significant when written in correct scientific notation. So for example, an alloy contains 2.05% of some impurity. How many significant figures are reported in these values? No? If asked sa mga inani, no, always go back to the rules sa significant figures. So the solution is that all digits reported are significant. So there are 3 significant figures in the number. Why? Because ang 0 man kay 0 is included because gitungan siya sa 2 significant values, which is 2 and 5. So there are 3 significant figures in the following problem. For the calculated values, no, the number of significant figures should be consistent with the values used in the calculations. No, for when you say sa significant figures, no, dili lang ta magbasta-basta og butang og 2 significant figures. Base lang tungod kay duha ra pod siya ka significant figures sa atong calculations. Naatay rules, no, for multiplication, for division, for addition and subtraction. For multiplication and division, the number of significant figures in a result must be the same as the number of significant figures in the factor with the fewest significant figures. No. So if, example, 0.24, how many significant figures are there in 0.24 kilograms? There are two significant figures multiplied by 4,621 meter. How many significant figures are there in 4,621 meters? There are four significant figures in the following in the equation. No? So it says here for multiplication and division, the significant figures to be followed is those with the fewest significant figures. So, i-compare nimo sa 0.24 kilogram and 4,621 meter, no? Na 4 kabok significant figures. It says here, fewest significant figures. So, atong i-follow si 2 significant figures lang. So, when you multiplied 0.24 kilograms and 4,621 meters, no? It will result to a 1,100 kilogram kilo m, no? Or since we are required to show it accordingly sa correct number of significant figures, no? So 1,100 is 4 significant already, which does not follow, no, the rule of the sa significant figures sa multiplication and division. So since duha raman, so we have to convert it into two significant figures, which is 1.1 times 10 to the power of 3 kilogram per meter. No? For addition naman and subtraction, the number of significant figures are determined from the position of the first uncertain digits. No? For example, 4.882 meter plus 0.3 meter. So, the answer will be 5.2 meter. So, when you say the number of significant figures are determined from the position of the first uncertain digit, no, it is the least decimal points that you can get. Since 4.882 meter has 3 decimal places versus 0.3, which is 1 meter. So, ang ato ang i-follow is ang pinaka-least na decimal place, which is 1, no? So, the way we express our answer would be 5.2. 1 decimal place lang since 1 laman po ang decimal place sa tong pinaka-least na digits. No? So again, for the multiplication and division, the fewest significant figures, no, i-express nato siya sa pinaka-fewest significant figures of the two numerical digits that you have or sa two na sa ato ang calculations. Now, for the addition and subtraction naman is the least decimal place. Now, always remember that in mind. So, for example, report the result of the indicated arithmetic operations using the correct number of significant figures. Assume all values are measurements and not exact numbers. So, the first one is multiplication. The second one is addition. The third one is division. Is division. No, from the first rule of multiplication and division, no, the least significant figures. So 4.30, no, 3 significant figures versus 0.31, 2 significant figures, no. Kinsa man ay lang sundon. So di ba si least significant figures. So it has to be expressed in 2 significant figures. For letter B, no, it's addition. So it has to be the least decimal place. So 4.033, no, we have 3 decimal place versus 88.1 with 1 significant decimal place. So ato ang sundon is 1 decimal place lang. We should express the answer in 1 decimal place. No? For the letter C, no, 5.6 divided by 1.732 times 10 to the power of 4, no, since it's division with the least number of significant figures. So we've got 2, di ba? Kaya 5.2. So again, since A is multiplication with the least significant figures, which is 2, so we'll express the answer by 2. 1.3, so it's 2 significant figures. For letter B, it's 4.033 plus 88.1. So it has, according to the rule, least decimal place, so only 1 from 88.1, so 92.1. For the letter C naman, it's 5.6 divided by 1.732 times 10 to the power of 4. So since according to the rule, no division, we have to follow the least significant figures. Since 5.6 has only the fewest one, so we have to follow 2 significant figures. So the answer will be expressed in 3.2 times 10 to the power of negative 4. So when counting discrete objects, the result has no ambiguity. So such measurement uses exact numbers. They have infinite significant figures. For example, 2 pennies would be 2.00000. It's nonstop. No? So exactly defined terms such as metric prefixes are also considered exact numbers. No? So there are several categories of problems. No? We have calculations involving ratios. We have conceptual understanding of particulate level. And we also have visualization of phenomena in different levels. So there are these problems that we can calculate using numbers, using ratios. We also have problems that we can conceptualize, understanding of particulate level, or those in microscopic one, and then visualization, those that we can only express through visualization because it's on a nanoscale level. No, when using ratio, ratios represent the relationship between two quantities and can be expressed in two ways. No, for example, we have price is 4.45 dollars over 5 pounds. So we can express it through $0.89 per pound. But when you interchange the two, 5.0 pounds for $4.45, no, we can also use 1.1 pounds per dollar. No? Kung kinsay una, kinsay on top, no, siya pud ang una na i-express over the ones that are below. So for example, suppose that your supermarket is offering 20 count shrimp for $5.99 per pound. How much should you expect to pay for a 1 dozen of shrimp? So you have there 5.99 for 20 shrimps times 12. So you have $3.59 for a dozen of shrimp, no? That's the calculation. So the supermarket, no, is having a 5.99 sale for a 20 shrimps. For its 20 shrimps, no. And then you just wanted to have a 12 pieces of shrimp, no? So para makalas ka or naara ka sa ang imong budget is just below 5.99, and para makatipid ka, you just wanted 12 shrimp lang. So all you have to do, no, is calculate using the following. 5.99 over 20 shrimp multiplied by 12 shrimp. Why inana siya calculation? In order for you to cross out, no, as you can see, ima-cross out nimo ang duha ka shrimp. Si shrimp sa baba and then shrimp and above. So it will be, pag imo siyang i-cross out, mawala na ang shrimp. So the remaining will be the dollar sign, $3.59. So that's the trick, no? Kinahanglan nasa baba si shrimp, and then si shrimp is ka-level na in order for you to cross out shrimp, and then ang mabilin si dollar sign. So for the mass density ratio of an object's mass to its volume, so its mass density is described as the ratio of an object's mass to its volume. So its mass density, object's mass to its volume, And then we've got here the temperature is a compound specific. So it allows conversion between mass and volume. So when you say mass density, it allows you to convert a certain volume and mass. So for example, you have 346 liters. So you want to convert that liter of water into grams. So how will you do that? So first, you have to convert 346 into millimeters. So as we all know, 1 liter is equivalent to 1,000 ml. So there you can see in the first part, 346 liter over 1 ml, for over 1 liter by 1,000 ml. Now, the density of water in room temperature is, as we all know, 0.975 grams per ml. Asa man nato ni nakuha ang density sa water? It is also based on scientific experiments. No? Si water daw in room temperature is 0.975 grams per liter. So, exact na siya. Mo na gid na ang iyahang fix na density for water. So we will use the density of water based on calculations in order for us to cancel out ml. So since liter is cancel out na, si ml is cancel out na. So what will be left out will be the grams na. So by then you will be able to get the mass of the 346 liter. So the units of measurements can be used to determine how to write the appropriate ratio by canceling out, or it is called the dimensional analysis or the factor label method. In order for you to get the volume, in order for you to get the mass, the mass of a volume, you have to use the canceling out or the dimensional analysis or the factor label method. Later, guys, I will be sending you a videos on how to cancel or factor label method for those who are still finding it hard to grasp the concept. So for example, what is the wavelength in meters of strange orange light of wavelength 615 nanometer? So 1 nanometer, 1 meter is 1 times 10 to the power of 9 nanometer. So in a nanoscale. So kung imo siyang factor out, it'll be 1 m over 10 to the power of 9 meter. That's how nanometer is being expressed into meter. So we've got here, pila daw, what is the wavelength? So ang wavelength is expressed in meters. So pila daw ang wavelength in meters of an orange light with a wavelength of 615 nanometer. From nanometer, we want the result to be expressed in meter. So using the canceling out, the canceling out factor label method, 615 nanometer by 1 meter over 10 to the power of 9 nanometer, cancel out nanometer is now equivalent to 6.15 times 10 to the power of negative 7 meter. Don't forget still to follow the significant figure rule. So yes, using always remember the canceling out method and the significant figure when expressing answers to your scientific calculations. Another example, the density of water at 25 degrees Celsius is 0.997 gram per ml. So a child's swimming pool holds 346 liters of water at this temperature. At what mass of water is in the pool? So ang swimming pool daw holds 346 liters of water at temperature of 25 degrees Celsius. So gusto na tumabalaan kung pila ang kilogram or pila ang gram sa water in the pool. So same method, canceling out and using the density. 346 liter times 1,000 ml in 1 liter, times 0.975 997 grams over 1 liter, which is the density, no? Using the canceling out, cancel liters, cancel ml. So what will remain will be the grams. So overall, the calculation is 3.45 times 10 to the power of 5 grams, no? Still following the significant figure rule and the scientific notation. So for tonight, that will be all. For tomorrow, no, we'll have a short quiz onto the naming of the periodic table and some simple chemical um, no, chemical problem solving, no, especially on to the assigning of units and significant figures. So any questions will be answered tomorrow, or if you have answer, please do type it sa ato ang GC. So that will be all. No, everyone, thank you for listening and have a great night.